Hi everybody. Today we are going to learn about Simscape toolbox in MATLAB. Okay. So what we are going to learn in this video means what is Simscape, some related shortcut keys, what is the difference between Simulink and Simscape, basic knowledge on Simscape, and at last we will do modeling of lithium ion battery equivalent circuit model that we call as ECM in Simscape modeling, and we will check by doing its simulation. Okay, yeah, we'll go to the next Simscape model toolbox. So Simscape is useful for modeling and simulating multiple models, so multi-domain physical systems. Okay, so it's like just an extended to the Simulink toolboxes, and Simscape is also a type of Simulink toolbox, but it's an extended flexibilities it is given, like electrical, mechanical, gas, hydraulic, and all sort of modeling domains it will facilitate to us with an extended support for the better simulating to the physical systems that we need in our engineering applications to do. Okay, Simscape supports units. Units means like in while we are doing in in academic years in the textbooks, like we have units like for example resistor it's ohms, for power it's watts, for energy it's joules. In the same way, Simscape also allows us to put units while we are updating the device values. For example, capacitor value I'm updating like 2 microfarads, then I can put 2 and microfarads also. So microfarads also I can indicate in the physical system models. So that is the meaning of Simscape supports units. Simulink will not support units. Okay, Simulink is based on the equations derived from the physical systems. Okay, it is like a signal flow. So there units are not support, but Simscape will support units to um, indicate in there. So there are some shortcuts to use this. So if one shortcut is SL library browser, okay, if you use this shortcut in the MATLAB command window, like you see here, SL library, SL library browser. So capital B we should use browser. So what will happen? The Simulink library will open now. SL means Simulink library browser. So Simulink library will open like this. So this is Simulink library we have here. Okay, and if you go down, scrolling down, you will get here Simscape library. You will get here Simscape library. Under Simscape library, we have foundation library, utilities, battery, driveline, electrical, fluids, and multibody. Some in some versions for MATLAB, it shows like sim driveline, sim electrical, sim fluids, sim multibody, and sim battery, sim foundation library. Like okay, these both are same. So under foundation library, you will get again different fields of domains. This is electrical domain, this is gas domain, this is hydraulic domain, this is isothermal liquid, magnetic, mechanical, physical signals, and thermal and thermal fluid and phase fluid. So different domain of physical bodies you will get here. So I am going to one of these one, electrical domain. So I went into electrical domain. Under electrical domain I am clicking on electrical elements. Okay, it was shown here electrical elements like capacitor, diode, electrical reference, and all related things are shown here. Okay, and in elements, electrical element, the physical body, this work in the design in our model like same the physical, how we calculate in the normal problems while we are reading any electrical circuits about anything. like transformers or whatever it is. In the same way, this circuit also will work, and the physical thing that you are seeing on the paper, the same way you can connect these models in this physical system modeling by using these devices. So these are the connecting elements. And sensors is there. Sensors means like here in electrical we have current and voltage. If you know these two, you can find out power. So in the same way here, uh, to sense the current through the element is current sensor is there, and to sense what is the voltage across the element, a voltage sensor is available here. So both sensors are available in electrical sensors. And sources, in electrical sources we have like AC source and current source, voltage source, DC sources, and current control, different current control voltage source, current control current source, voltage control voltage source, voltage control current source. Several types of source we have, right? So all are available here in this one. This is about electrical domain. If you go to gas, all gas elements, sensors, sources, and utilities, everything is available. So in each domain you will get its elements, sensors. Sensors means the like you can understand like a meters. Okay, it will sense that required pressure, it will sense the flow rate is through, pressure is across. So that is the things, it will sense to measure the things, the sensors will be given. And sources means the the source of the ideal source, what requires to drive that model, it will get from here. And utilities like the supportive things, what to the model. And if you go magnetic, here also elements, sensor, sources. So in each model you will definitely get elements, so sensors and sources. And in some of that you will get utilities also. Okay, in some of utilities also you will get, for example in electrical you are getting three elements, sensor, sources. And in thermal, elements, sensors and sources. But if you see, just now we see in the gas there is utilities also. Okay, yeah, so, some of the domains have utilities also. In mechanical, see, you have different mechanical sensors, mechanical source, and mechanism, types of mechanism, and multi-body interfaces. In multi-body interfaces, if you go there, rotational multi-body interface and translational multi-body interfaces. Okay, rotational elements. So in mechanical, two types of them. It's rotational and translational, both rotational and translational. See, rotational and translational. Translational is nothing but we should be very careful here, and we should have some sense what is translational and what is rotational. So translation is a body movement. Translational is a body movement one place to another place, and rotational is body movement plus rotating, spinning itself. So rotational and translational, both understanding should be very careful while doing the model of mechanical system related. Okay, and thermal, it is we've seen already, and here utilities is there, and here utilities is there. As I said, in some domains utilities is present, and some domains utilities is not present. Okay, so this is Simscape library. In Simscape library, utilities is there in network couplers. See here, network couplers, like one network to another network to couple it. And driveline system. In driveline system, for example, I can say in vehicle modeling, the driveline, the energy driveline from the source to a mechanical output, that body movement, the car body movement. So how it will be there, like engine, motors, gearbox, and inertia loads, that sensors, and tire and vehicle, and transmission, how it will go. So all the blood that clutches and brakes to design for the uh, uh, car modeling. So we will get all this here. Okay, tire and vehicle. So here this is vehicle body model. We will do vehicle body model, tire magic formula, like to design the tires, and to check it, everything is available here in this box of driveline. This is we call normally sim driveline, we will call it, generally in the technically. Okay, and electrical, we have several departments. So in the foundation library, electrical is there, that is different, and this electrical is different. This is one sim electrical one. Okay, so here passive devices, the line and everything. See how we have star connected, delta connected, everything. Okay, yeah, these are one thing. And fluids, yeah, in the fluids also we have different, and multi body gear coupling and everything, like nowadays mostly useful in a vehicle, electrical vehicle uh, simulations. Okay, this is about Simscape. Okay, and we saw about Simulink also. Okay, in Simulink, for example, sinks, you see in the sinks, mostly useful for us. In the Simulink we have display and scope. In this scope is useful to see the waveforms that we are opting out to check, and display, any output to display we will use it actually. Okay, and terminator to any connection, any end to be terminate properly, means in the Simulink this terminator will be useful. Okay, yeah, that is about Simulink and Simscape. Basically we need to know while we are learning about Simulink and Simscape. Okay, so going back to our presentation. So the next shortcut is SSC new. So how SSC new will be work? So SSC underscore new. If you click this, what will happen? The new untitled Simulink, page will open. So this is what it is. Okay, new Simulink. This one will this is opened because of I used this shortcut keyword here. Okay, in other way you can click on Simulink and go. If you click on Simulink, it will open this box. So this Simulink window. In this one, if you click on blank model, it will open. Wait, yeah, it is open. So what is the difference between these two means? This is I went by clicking on Simulink and taking new model. So this untitled one Simulink is open. So in this blank model, I don't have uh, any models without I am bringing it from the library. But whereas I opened the same by using the keyword, whereas I opened by using the keyword this one, the untitled Simulink, and whereas I opened untitled Simulink by going Simulink actually with the actual process without keyword, without short key. So by using short key, the helpful thing is the model will open automatically along with the useful devices in the model. These are useful devices in the model. Why? Because SSC means Simulink Simscape. Simulink Simscape. So in that, for any Simscape model, these are the compulsory and necessary models we should keep in the model. Okay, why? I will explain this while I am doing the battery model ECM. I will explain this. Okay, why these are things. So I just delete this text. This is not required for us. I am just deleting. Okay, I also will close the extra one we opened, right, untitled one Simulink. I am closing this. Okay, so this is one thing we opened by using this short key. The useful blocks are automatically came to the model. Okay, that will load by inbuilt, it will open this. Okay, I'm going to my presentation again. And I said it, Simscape will support units. So what are the units it will support? To know that, you can give this keyword like pm underscore get units. In command window, it will show all the units that it will support. Pm get units. So it will show every unit that MATLAB can in the Simscape, what are the units it can be supports, like uh, meters, kg, kilo means kilograms, and seconds, and coulombs, okay, and k, mole, mm, moles, and centimeters, and mm, and kilometers, and micrometers, and degree centigrade, degree Fahrenheit, okay, or yeah, these are degree centigrade and for delta degree, okay, inches, feet, all of this, lbf, all kn and mg. So all of this, kilohertz, megahertz, mph and kph, and revolutions, and degrees, radians, microsecond, millisecond, nanoseconds, okay. So there are so many types, it will mpa, kpa, okay, so many types of units it will be supports this MATLAB will support all of this, okay. 130, it is 130 by 1 means one column, and 130 rows means almost 130 units Simscape will support in the models, okay. Okay, these are about some knowledge about Simscape, and we'll see what is the difference between Simulink and Simscape. Okay, Simscape is an extended thing for the Simulink. Okay, that we know, because in the Simulink only Simscape is present for the modeling of physical systems. So Simulink, the models can build from the derived mathematical equation from the physical model using integrators and other mathematical operations. It is like signal flow, it is like signal flow connection, and it is an unidirectional flow type. Simulink diagrams always that performs it flow path from source to output, from source to output manner only it will works, okay. From left to right, the signal flow will be happen in the Simulink models, but in Simscape it's not like that, okay. Simscape we use physical elements, it's like physical connections, it is bidirectional too, it is bidirectional too, okay. I will explain this in clear in my next slides. It is bidirectional too, it is not unidirectional only, it might be uni or bi, okay. In both ways Simscape might be possible. And Simscape have different type of field domains, different types or field domains of physical model that requires in engineering modeling, okay. For example, electrical, like just now we seen in the MATLAB directly, that sim electrical, like hydraulic, mechanical, and magnetic, and thermal domains, etc. There are gas, fluids, everything we see in there. So in the same way, Simscape having different models, different field of model, different domains, we can call it as domains: electrical domain, hydraulic domain, mechanical domain. And in mechanical itself, there is two: mechanical rotational, mechanical translational, and magnetic domain, and thermal fluids and thermal domain, like different domains, okay. And Simscape model can be a multi-domain model. Multi-domain model means a single Simscape model maybe have electrical domain plus mechanical domain. For example, electrical domain means a battery is connected to DC motor, and a DC motor may be connected to mechanical system, that is a gearbox. For example, if you think about, if you imagine about, um, the battery supply is given to the motor, motor will rotate, and the rotating force is connected to uh, ideal, I can say ideal torque. No, instead of ideal torque only we are taking this one. So torque is connected to this motor. What is the torque generated from motor to gearbox? Okay, so the gearbox will drive the output. Okay, like 1 east or 2 east or 3 east. Okay, in such a way, so by using the type of devices like motor, electrical intake, and mechanical output, okay, but that you can club the both mechanical part and electrical part and mechanical part, so which has two domains, electrical domain and mechanical domain. That means a Simscape model can be a multi-domain model, can be a multi-domain model. Okay, this is clear. The one more thing is, for example, electrical domain elements are there, so you can collect electrical domains easily, it will get connect. But directly from electrical domain element to mechanical domain element, it won't connect, it won't connect. Like in between these two domains, like one side mechanical domain elements, one side electrical domain elements, if you connect them directly, it won't get connect. Okay, so you need like a DC motor, like a DC motor or the converter or the box. Okay, you need that when electrical is connected to one end and output is a mechanical, then mechanical side will connect to mechanical domain, electrical side will connect to electrical domain. Okay, for example, I will show you that we have Simulink library, and here if you go to Simscape, if you go to Simscape and foundation library, in the foundation library, okay, you go to drive line, in the drive line, so I am taking this engine motors, engine motors. Okay, it's not there, so I will take, uh, just I am checking that where it is available. Electrical, checking it, electromechanical, BLDC motor, no, not getting, like DC motor we will get it, transmissions, its engines and motors. I am just checking, in Simscape library, electrical sensors. Okay, electrical elements I will go there. In electrical elements, if you see rotational mechanical converter, okay, rotational mechanical, I am just taking this element to our untitled model. This is our untitled model. I am just grabbing it to this model for the better understanding. Okay, I have did it. So here, if you see, this is electromechanical converter. I hope you are seeing that annotation name, rotational electromechanical converter. So what it is, it takes the battery connection from this side, and this is mechanical output. This is mechanical output. So these device can club electrical and mechanical. So in such a way, Simscape, Simscape, it is possible in the Simscape, it is possible in the Simscape, uh, it is possible in the Simscape to be a multi-domain model, to be a multi-domain model, and to build multi-domain model by using the model links like Mona. Yeah, already we discussed this point now. Okay, yeah, we'll see the next slide. Okay, so yeah, we learn about what is Simscape and what are the some useful shortcuts, and what is Simlink and what is Simscape, just the difference between these two. Okay, now we say the ECM, that called as a ECM in technically in designing of vehicle battery. So just I am taking like equivalent circuit model ECM of lithium ion battery. Okay, this is a lithium ion battery, a single battery equivalent circuit. And if you stack it, if you stack one battery to another battery like 10 20 like that, so it will go in this way. Okay, this is one battery and this is another battery, both are stacked, both are stacked in a way that will add the V battery, that both are stacked and give, means it is a series connection, and it will give V output, more V output. Okay, yeah, we'll check this. in Simscape model that we already opened, untitled Simscape model. Okay, we will check in that. Yes, this one. I am just deleting this, which is not required for us. Okay, for present. Yeah, I am also uh, I am also deleting this one. So we are simulink to physical converter. This is simulink signal to physical. See, one more thing here. Simulink signal and physical modeling signal both are not same. Both are not same. So here we need a converter, a physical signal, physical model connection to simulink converter. This is one. If I want to see, and if I want to get something from simulink to physical model means I need to use this one. If I am going to see something from physical model in simulink means this is the converter. Okay, so I am deleting this. I am not required. I don't need this now in my present model, so I deleted this. I am keeping this one. When I am connecting this, I will explain why it is required. While I am connecting this, I will explain again why it is required this. Okay, so it is one voltage source I need, and one resistor, second resistor, one capacitor I need. Okay, this model only I am building now. Okay, so I want to go. Yeah, actually we can do by shortcut by clicking anywhere in the free space, this in the free space. By clicking like this, you can type like DC voltage, DC voltage source, and from where we have to take the device here, from foundation library. See, you just see here, foundation library, electrical and electrical sources. Okay, in foundation library, in electrical, under electrical, under electrical sources, this DC voltage source is available. So I am clicking it. So this is where it is available. Again, I am going to library. Okay, this I already opted it. I am just showing this in Simscape, in Simscape, in foundation library, in electrical, in electrical sources, in electrical sources. I have this DC voltage. I am again taking grabbing it, DC voltage source. So it is showing like annotation. Okay, it is showing like annotation DC voltage source 1. This is DC voltage source because already one device is there, the same one. That's why it came as a one device, like its name. Okay, the annotation showing like DC voltage source 1. So one voltage source I required. The both ways you can choose, but first in practicing way, it is better to go library and go to that place electrical sources under foundation library, which is under Simscape. Then choose your required source one. Okay, so presently I am deleting this one. Okay, I shown in both ways to for the better understanding. Yeah, another thing what I need an element, resistor element. So I am minimize this. I will open electrical elements. Under this I need a resistance, a resistor, right? So my resistor is here. I am just grabbing this here too. Okay, so I need another resistance. Instead of grabbing another resistance, I can do like this also. I can do grabbing second time. Okay, so instead of doing that, there is one short key. What we have to do, you click on this one and give control press in your keyboard, control press, and put your left click, and grab it like this. It will get copy and move the other resistor also like this in the back. So control, keep press control and click on this element and grab it. Keep control and grab it. Keep control pressed and grab it. Like that you can copy the devices how many times you need it. Okay, instead of going to library every time and pulling from there, grabbing from there, instead of that you can do. And other thing I need for my model, I need a capacitor. So I have taken one capacitor also from there. Okay, right. So what I need to do, I need to connect this all. I need to connect this all as my model is saying voltage, resistor and capacitor and these things. Okay, so I am going to model. I am just connecting. So how we can connect? I can connect from here to here. Okay, and I can connect like this, or one way I am choosing. First I will connect these two, and next I will connect this one. Okay, connected. And this end also should go here, right? Yes, this end also should go. And I am just adjusting my connection to look uh, good and not be like a clumsy way to confuse. Okay, I have done it. I have done it. So I'm just making it something. Yeah, I done it. Okay, okay, sorry, it is moving here and there. Yeah, so now I have to change the values of this. Before that, see, the resistor name is not showing, resistor name is not showing, capacitor name is not showing. When I'm moving my cursor only, the name is coming below. But I want for my understanding what I am connecting, how I am connecting. So for that, what I am going to do first, I will show for this one. You click on this right one. Okay, you click on this, right click, and go to properties. Here block annotation is there, block annotation is there. So block annotation means yeah, here we have name annotation. Okay, name, click on name and click OK. It will show the name. Black annotation, yes, it is there. Okay, we have to do this operation. Wait, name I selected and click on this, it will go here, name. Okay, and and it one more thing we can do. Yeah, its name, it's there. So if you click this, its name will be displayed here, DC voltage source. And for this one, resistor, if you want to add this black annotation, so what you can do, you can do like this. Okay, instead of taking name, if you take the name, what will happen, the resistor name will show. What will happen, resistor name will show. And if I take like this, like r I took here, and unit also I took here, unit also, what it will happen means, r is how much value I am taking. For r is 2 ohms, 3 ohms, how much, 3. If I give 3 now, that 3 will show here. So I am just making like this, keep a bracket and keep bracket. Okay, so I am keeping it. Okay, so what it will happen, it will show its resistor value and units, both it will show. So for understand, I can understand that as a resistor, right? So I am doing that. So what it is showing, 1 ohm, 1 ohm, and its units also. Okay, and here also I can do the same, right? Yes, annotation, and go R, move it to here, and units, move it to here, and just take to the line and give the bracket. So this line came to here by clicking delete. Okay, this is one line, this is a next line now. So if you click delete once, it will come to the previous line. So then you can put this brackets. So put it. Okay, and for capacitor also I will do the same, block annotation. Okay, and that is capacitor C, it's gone. So units, it's gone to this side, and one, you click on delete and brackets. So don't delete this percentage symbol, so it needs to show the values. Okay, yeah, e power minus 6, it is there. These are 1 1 e power minus 6 are by default values. but we have to change these values as per the battery model descriptions. Okay, battery model, how it is, how much capacitor and how much resistor values you should use, so that should be updated. Okay, so for DC voltage properties, I am just going back again. So what we can take here, um, name I have taken, tag type V0 I am taking, V0 I am taking, yes, V0 also I took. Mm, I just want to show the value also. Yeah, okay, let's check this by doing. I will do update it again. Okay, it's units. Okay, it's came, and now I am double clicking it. How much value? So I will keep this like 4.5 volts. 4.5 volts. I am just unclicking and clicking again. It is auto apply 4.5 volts. Like it is 4.5 volts, it is showing, and here I am changing like my resistance like 0.093 0093 ohms. I'm keeping, just unclick and click again, it is auto apply, and this battery I am just giving like 1.3 ohms, just unclick and click, it's auto apply. Okay, and for capacitor I am doing like everything is same series. I am not updating anything, I am not going to disturb anything. So but this this capacitor capacitance only I am going to increase for 500, for 500 farads. Okay, for my device I chosen these values. Okay, you can choose as per your prescriptions, that whatever you have. I am just unclicking and clicking again for auto apply. Okay, so values also it is showing, right? Values also it is showing. So here what I am doing, so I drawn it, but here what are the essential that we need to go, what we need to, in physical modeling, Simscape physical modeling, if electrical modeling I am doing, that needs electrical reference connection, definitely and mandatorily it is necessary. Okay, so for that I have to take like electrical elements it is there. I just checking in which it will available electrical reference I need. Okay, electrical sources it is there, no. So where I can find it, electrical reference I need. So if you go electrical, can I get it in utilities? No. In sinks, additional components, no. Controls, no. Passives, no. No. If I check in sinks, no, it is not available. So I will write here to get that electrical reference foundation library electricals and electrical elements. So we will check there electrical and electrical elements. Electrical reference we need, no? Where is that? Yes, yeah, electrical reference I need. That simply we call it as a grounding. Okay, electrical reference. Okay, neutral. Okay, electrical reference I connected. So after that, there is another device that must and should for all the, see, this is electrical model, that's why I connected electrical reference. If it is mechanical model, I need to connect mechanical. I need to connect mechanical. Okay, in mechanical elements it will be there. So if for example it is rotational na, mechanical rotational reference. For example, it is translational na, translational mechanical translational reference. The reference element must be connected to the model. Okay, and this reference element is depends on the model, what type of domain you are connecting, that domain reference should be connected. This is electrical, that's why I connected electrical. I cannot connect here mechanical. Okay, for example, you see mechanical rotational reference. Okay, I will try to connect it, it won't connect. Whatever I do, it won't connect. Okay, just now I explained right about the thing. Same domain elements only will get connect. If not, there is one intermediate box we need to use like a motor. Okay, so this one, about this one, this is a solver configuration. To to simulate this one, we need this solver configuration, and you can connect this box anywhere in the circuit, either here, here, anywhere. For example, there are complex circuit it is. This one you can connect anywhere to any across element through any element, that you can connect anywhere, just touch it to the circuit that is needed for the physical modeling. Okay, this is definitely required, this one definitely required based on the domain. This is with irrespective of domain. If it is Simscape model, this block is compulsory, should be there in the model, and it should be connected somewhere. It's not the matter where you are connecting it. Okay, fine. So for example, I'm going to use this now. Okay, so if I want to connect this, I cannot connect it. It won't connect because this is a Simscape, this is a Simulink. You understand it. So this is a Simulink, this is Simscape. It's not possible to connect these two. You, it's failure, you cannot connect. Okay, I am deleting this. So what do we need to do, what we need to do now? So I need, for example, I want to see the current, how battery is discharging, I want to see that. So what I have to do, I need to connect, it's a electrical uh, simscape simscape model, right? So in the electrical simscape model, if you go electrical simscape model, okay, in the foundation library, electrical model, I have I want to check current discharge, how this battery is going to discharge when some load is connected here, some load is connected here. Then so I have to take current sensor. Okay, I have to take current sensor. So current is through the through element. So through element means current should pass through the my current meter. That is simply in this Simscape language, it is a sensor, current sensor. Okay, now you just imagine, sorry, you just observe this, these all are coming into the blue color, but this port, this output port, this one is only coming in black color. So I can connect this current to this block. Imagine, so this is Simulink, this is Simscape model, this is Simulink model. In between these two, there is this device is useful to connect. So the current flowing in this branch I can read here. Okay, so this is Simulink, this is electrical domain, Simscape, this is Simscape, this is Simulink. So by using this current sensor, I can go and read what current, how it is in starting using a battery, and after some time how it is discharging, that I can see here. Okay, okay, I hope it's understood, right? So for some simplicity, I am bringing these tools here, something to look some good. Okay, should not be a complex to understand in better way. I am just closing this library. Whenever it is required, I will open again. Okay, so I given my values. This is 4.4, 4.5 voltage, 4.5 voltages, and this is 0.0093 ohms. This is 1.3 ohms. This is 500 farads I given for my battery model. Okay, one solver I work configuration I connected because it is required for the Simscape models, whatever it is, and one electrical reference I connected because it's compulsory should be there, right? So now I just want to select the solver for this. I just want to select the solver for in the Simscape. Okay, so just click right click somewhere on the model in untitled simulink, and you go to model configuration. So here you have different solvers uh, to use. So but for the variable model, if it is for the solver for Simscape models, for variable type solver selection, so there are different solvers. Okay, there are different. So but the best suitable thing is ODE 15S, this one, or ODE 23T, this one. 23 TB is also there, not TB. I am not talking about TB. I am talking about 23 T only. And if this is fixed, if the type is fixed step, then the solver is simply like 14x ODE 14x extrapolation. This one it is advisable to use these solvers like this one. Okay, if it is variable step, so I advise it ODE 23T to use. Okay, the model solver. I am using this 23 ODE 23T mode dot stiff trapezoidal solver for variable step. Okay, so I am simply, for example, you give this one maximum step size, it is there. Yeah, no need to uh, change it, but if you change, you can change, but don't change more than E4 minus 3. Okay, maximum E4 minus 3 should be there, right? So I am not changing anything. I am just applying and clicking OK. So MATLAB solver configuration I set it. So now it is showing 23 T ODE 23T as my solver for this model. Okay, now see here the model 10 seconds it is there, 10 seconds it is there. I can change here my simulation model. I can change. Just now we seen, right, model configuration. So here also you can change the how much time you need, stop time and uh, start time and stop time. See, it is 10 seconds it is there, here also 10 seconds it is there. And for example, I can use 100 seconds. For example, I can use 100 seconds. If I click OK, this also will become as 100 seconds. You can see. Apply, and yeah, see, once I click apply, here also become as 100 seconds. I click OK, both are 100 seconds. So either you can change here directly from the model, or you can open this model configuration, then you can say it. But directly you can change from here, no matter. Okay, so 100 seconds I am simulating this model. Just I am clicking to run. Yes, everything we settled down, right? Yes, yeah, click it. 100 seconds I given, it's taking some time. Yes, our model is simulated. Then we want to see output. we want to see output. So first it has uh, it is what we done, it is current we have taken, right? Current we have taken. So 500 about 500 amps to about 500 amps, nearly 500 amps to it was discharged within, here I can tell 35, yeah, within 35 seconds it was discharged, within 35 seconds it was discharged. So that is what, within 35 seconds it will discharge. After 40 seconds onwards, 100 seconds, it is become as zero, almost zero. If I bring this, okay, I put like this, yeah. So flexibility in it, yeah. So if my capacitor value, if my capacitor value changes like 100, like 100 farads, what will happen, we'll see. Okay, it's automatic. So here also 100 is changed, we no need to change manually. If you change the values, these annotations directly will changes automatically. Okay, once click save, and I want to save this model. I am saving this model like lithium li underscore lithium battery, right? Li underscore ECM. Okay, I saved it like li ECM. Yeah, I have changed the value, no, so that's why I saved it. Okay, I I want, yeah, this runtime of 100 seconds is same. I changed 500 to 100, and now again I am simulating how much time it will take. In previous, when it is 500, it's 35 seconds, and when it is simply 100 farads, how much time it was taken. See, it was taken very less time, within 10 seconds it was scooped, it was done, the battery is empty. Okay, so one more thing, we can do this thing like I am just uh, extending this to show that. Okay, I can keep the name of this signal, they can name of signal. So what I can do, current I can put, right? Current in amps, current in amps, yeah, I given the name for that one. So let's check whether it is amps or what it is. Code, it's not opening. Check the properties, black annotation. Yeah, I'm just giving name, current sensor. Okay, I'm just giving name. So it is opening like so I just want to see and run again. So current amps, current in amps, it is shown the name of this plot. Okay, so I am just going back, saying this or so this not show changing directly. So I am going this like 8000 farads. Just click and click, it will apply automatically, and just save this model. And just for changing, if capacitance is less, then battery discharging very fast. If capacitance is more, battery discharges very slow. That some difference I want to show here in this model. See, battery is not discharged even 100 seconds, it is even 100 seconds battery is not discharged. If I take 500 seconds, at nearly 480 seconds it was decreased to zero. Before that there is something current is there. Okay, so for vehicles, for example, if the lithium battery is using in vehicle, means the capacitance of the battery should be more, then the battery will discharge slowly by giving required charge to run the vehicle. Okay, battery discharge is very slow. So that is one thing. So this is Simscape model. This is Simulink model. Between these two, it was connected by using current sensor. So I hope this is understood. ECM. This is the ECM of lithium ion battery. Okay, and we have seen this is single battery. This is single battery. Then this is two double RC networks. You see, double RC networks. Yeah, how to do that? So the thing is, we can use subsystem. We can use subsystem model in Simlink, sir, in Simscape. So how we can use that subsystem model in Simscape is nothing but it is another session. It will become bigger session. This to shorten this, I will do that. How to stack one battery and second battery and third battery to improve the output voltage and the capacity of the battery pack, how it will do. So I will make it another session. This is becoming bigger to get understanding. So please subscribe to this channel. You will get real understanding for each and everything. Please comment if any doubt you have in this video that I have done. So please encourage by doing subscription. Yeah, thank you all.